In this lesson, we study the apportionment methods proposed by Jefferson and Adams. Historical apportionment solution number 2, Jefferson's method, proposed by Thomas Jefferson. So remember that in Hamilton's method, we divided every state's population by the standard divisor. Then we rounded the result down. Up until now, things seem pretty fair. We have treated every state exactly the same. It's when we start handing out the surplus seats that some of the states might start to complain, like, why did they get the extra and I didn't, etc. So Jefferson's idea was, what if we just change that divisor a little bit so that once we round the quotas down, there are no surplus seats. There's nothing extra to fight over. So to make this idea work, we need the quotas to be slightly bigger, right? We need the quote, because right now, once I round them down and add them up, there's extra stuff, right? I don't want to have any extra stuff. So I want my numbers to be a little bit bigger. Okay? So in order to make the quotas a little bit bigger, our divisor needs to be slightly smaller so that it will go in, when you divide, it will go into the number more times. So let's revisit Parador's Congress here. This was something that you worked on in your activities from last class. This time we're going to use Jefferson's method to apportion the seats. So my populations for each state are given here, A, B, C, D, E, and F. We've got a population. When you add them all up, you get 12,500,000 people. And I have 50 seats to give out. I think 12,500,000 divided by 50. Nope. I have 250 seats to give out. You might remember that from when I first introduced Parador's Congress. We're going to apportion 250 seats. So to get the standard quota, we take the total population, 12,500,000, and divide by 250. And that comes out to 50,000 people per seat. Every 50,000 people in a state, that gets that state one seat in Congress. So 50,000 people per seat. So I divide each state's population by 50,000. So I take 1,646,000, divide by 50,000, and you get 32.92, the standard quota for state A. So I've done that for each of these 6 states already. I got the standard quotas. I divided each population by 50,000 people per seat. And when you add those up, you should get exactly 250 seats. Now, my lower quota is going to be 32, 138, 3, 41, 13, and 19. Just rounded everything down. So I add those up. I have 32 plus 138 plus 3 plus 41 plus 13 plus 19. That's 246, which is too few. I need to give out 250 seats. Okay, so in Hamilton's method, I would choose 4 states to get my extra seats. But in Jefferson's method, we don't want to have any leftovers. We don't want to have anything we need to give out. So 246 is too few seats. So I make my modified quota. I modify my divisor. Instead of using 50,000, I want it to be a little bit smaller. How much smaller is a tough question, but we're just going to lower 50,000 to 49,500 and see what happens. Okay. In a couple minutes, we're going to discuss how to think about how much to lower it by. But let's see what happens if I divide each state's population by 49,500. So state A, we get 33.25. And state B, 6,936,000 divided by 49,500. And I get 140.12. and then 154,000 divided by 49,500, and I get 3.11, and then 2,091,000 divided by 49.5, 42.24, 685 divided by 49.5, and I get 13.83, and 988 divided by 49.5, 19.96. Okay, the total here doesn't have any meaning because we've changed the divisor. It's no longer exactly 50,000 people per seat, so we don't have to bother adding those up. What I'm going to do now is round everything down. Just like we did with Hamilton's method, I just use a different divisor. And I'm hoping that once I round everything down, I won't have any extra seats to give out. So 33.25, that rounds down to 33. 140.12 goes down to 140. 3, 42, 13, 19. Let's add those up. 33 plus 140 plus 3 plus 42 plus 13 plus 19 adds up to exactly 250 seats. So I've given out 250 seats using Jefferson's method. I had no surplus to give out, just divide, round down, and everything should come out to 250. So my final apportionment is 33, 143, 42, 13, 19. Now, there is a problem here. State B, I've got a little issue. Their standard quota was 138.72. That's the exact number of seats they deserve. And really the only fair thing would be to give them 138 seats or 139 seats, right? Either round it down or round it up. But we gave them 140 seats. So that could make some other states mad, right? State B got more than its upper quota. Right? It seems like the only fair thing in an apportionment problem is to give a state either its lower quota or its upper quota. But we gave B more than its upper quota. And that might make some of the other states angry. So here's just a summary of what we do to find Jefferson's method. Calculate the standard divisor and use it to find each state's standard quota and lower quota. Find the sum of the lower quotas. If that sum is the exact number of seats you need, you are done. If the sum is not, you have to find a modified divisor, D. And I have a little flow chart to help you find D. Then using D as your new divisor, compute each state's modified quota, which is the state population divided by this new D. Round them all down, add them up. If it's the number you need, you're done. And if it's not, go back to step 4. So here's a little flow chart for how to find a new divisor. Okay. If your sum is basically, it's if your sum is too small, make D smaller and start again. If your sum is too big, make D bigger and start it again. And a very loose guide for choosing how much to change D by is 0.5% for each seat off. So we'll work through how we came up with that 49,500. Okay. Using the flowchart. So always start with the standard divisor and then adjust as needed. So I've got my standard quotas, rounded them all down, and then I came up with 246 seats, which was too small, right? So I need to make D smaller, right? When you're too small, make the divisor smaller. When the sum is too small, make the divisor smaller. So I'm off by 4 seats, 246 is 4 seats away from 250. So 0.5% times 4 seats, that's about 2%. So I want to change D by about 2%. So 50,000, 2% to 50,000 would be 1,000. Okay. So 2% of 50,000 is 1,000. You just do 0.02 times 50,000 and you get 1,000. So I'm lowering my divisor by 1,000 here. So my new divisor is going to be 49,000. And I start the process again. I take each state's population, divide by the new divisor of 49,000, and now I get 1,646,000 divided by 49,000 is 33.59. So I get all new modified quotas, round them down, 33, 141, 3, 42, 13, 20, add them up, and now they add up to 252, which is too big, right? My sum is now too big. I want my sum to be 250. 252 is too big, so I have to make D bigger, right? I'm off by 2 seats, so I need to make D bigger by 1%, 0.5% for each seat off. So 1% of 49,000, 0.01 times 49,000 is 490. So I'm just going to go by 500. Okay, so I'm just going to make D bigger by 500. Do the whole process again. Take your population, divide by your new divisor, get new modified quotas, round them down, and when you add them together, and now we get 250 seats. So there is definitely a bit of trial and error involved in finding an appropriate divisor in Jefferson's method. Two other modified divisor methods were proposed as alternative to Jefferson's, one by John Quincy Adams and one by Daniel Webster. The only difference between the three is the rule that we use for rounding. So as we just saw, Jefferson's method rounds everything down. Adams' method rounds everything up. So the method is almost identical. We just are going to be rounding everything up. So when we want to look for a suitable divisor, if we're rounding everything up, we need the quotas to be slightly smaller, which means we should make the divisor slightly smaller. Sorry, we need the oh, whoops. All right, so to find a suitable divisor, we need the quotas to be slightly bigger. No, we need the quotas to be slightly smaller. We're going to be rounding everything up, which means we'll have too many things. So we need the quotas to be a little bit smaller, which means if you want the answer to a division problem to come out smaller, you need the divisor to be a little bit bigger. The thing that's dividing in needs to be a little bit bigger so that the answer will be smaller. All right. Same exact flow chart as with Jefferson's method. It's just that we have, in this rounding step, you bump all the quotas up. And then you use the same general rules for if your sum is too small, make D smaller. If your sum is too big, make D bigger. And again, loose guide for how much to change D by is 0.5% for each seat off. So here's a little mnemonic to help remember the methods so far. Hamilton's method, there's always extra ham to give out. Jefferson's method, a J looks kind of like an arrow pointing down, so that's the round down method. And in Adams' method, an A looks kind of like an arrow pointing up, so that reminds you that you round up in Adams' method. So I'm not going to go through an example using Adams' method because it's so similar to Jefferson's. I'm going to let you do that on your own in your activities. So I'm going to have you get started on your activities now, work through them, check your answers, which appear immediately after the activities, and let me know if you have any questions.